Chapter 3, Introduction, is a review of synthetic division and factoring. So after we synthetically divide the next 5 problems, we're going to write it in 2 ways, as you see up top here. This is part A and part B. We're going to write them both ways. So for number 1, we can do synthetic division since we are dividing by a linear term or a binomial that's a linear term. It can't be quadratic, it can't have a coefficient, or else we're going to have to do long division. So the first step is to take the coefficients of the dividend, what's on top. So 2x squared, the coefficients 2, -5, and -3. And then the factor that goes on the outside is actually the solution of that factor, so it's going to be a +3 out here, which is the solution to the factor x minus 3. So our first step is to bring this first number down, 2. Now we're going to multiply on the outside. 3 times 2 is 6. We add down, so we get 1. 3 times 1 is 3. We add down and we get 0. Now this last part of our solution I always box because this is our remainder. So in this case, we have no remainder. So when we go to write the solution to this, it's good to know that if we're taking a quadratic function of degree of 2 and we're dividing it by a linear function, which is a degree of 1, we're going to get a linear function. So it has a coefficient 2x and then +1. So in a final answer, that's what we're going to write down here, 2x + 1. And then in part B, we ask you to write it this way so you can know that to check your answer, whenever we divide, the divisor, which is that x minus 3, times the quotient, which is your solution, will give you the dividend, or what is being divided. Okay, so in this next problem, I'm going to take the coefficients of my dividend, which are 1, -3, -14, and -8. And since we're dividing by x plus 2, we have the solution of -2 on the outside. First step is to bring the first term down. So we have -2 times 1, which is -2. We add those down and we get -5. -2 times -5 is +10, which when we add those we get -4. And then -2 times -4 is +8. This is our remainder, and since it's 0, we don't have 1. So again, our dividend, x cubed minus 3x squared minus 14x minus 8 divided by our divisor of x plus 2 equals, now this is going to be a quadratic because we're taking a cubic function of a degree 3, we're dividing it by a degree of 1, a linear function. So we're going to get 1 less, which is a quadratic. And our answer is x squared minus 5x minus 4. And don't forget to also show that the divisor and the quotient equal your dividend. Okay, so this next problem is a problem where we're going to have to use placeholders. Okay, so placeholder means that if we start with a cubic term or a cubic function, we need to have a cubic term, a quadratic term, a linear term, and then our constant term. So if we don't have each of those terms, we need to put in a placeholder of 0. So essentially, up top, my dividend is missing a quadratic term. So I could rewrite this as, well, conceptually, this is what we're going to do. 2x to the third plus 0x squared plus 3x plus 7. So now we go 3, 2, 1, 0 as far as our degrees go. So the coefficients we use are 2, 0, 3, and 7. So if you forget to do this, you're just going to do 2, 3, and 7, and then you're going to run into some issues. So since our factor is x minus 3, we have a +3 on the outside. First step, bring down the 2. 3 times 2 is 6. 0 plus 6 is 6. 3 times 6 is 18. Add 3, you get 21. My last term is going to be my remainder. 3 times 21 is 63. So my remainder after I add is 70. Now, we are going to write the solution, but we have to also include the remainder, and this is how it's done. You have your dividend divided by your divisor, which is equal to your solution, or your quotient. And I really don't need parentheses, so I'm going to get rid of those. And then you add your remainder, but then your remainder also has to be shown that it was divided by our divisor. So this is how we write it. So if we were to write it the other way and had our dividend equal to our divisor, now that we multiplied it up top, and it's times our quotient, and then since we're writing it like this, we just add 21. We just add the 70 on the outside. We don't have to divide it because, again, we're bringing this x minus 3 and we're multiplying it essentially by both sides. So it doesn't need to be divided by the divisor. Okay, problem number 4. It also needs a placeholder. So we're going to start with our cubic, our quadratic coefficient, and we don't have a linear one, so this is where we need the 0. And then our last constant value is 7. And then we're going to do -1 on the outside. So we bring the 1 down. -1 times 1 is -1, plus 5 is 4. -1 times 4 is -4. Added to 0 is still -4. And then we have -1 times -4, which is +4, added to 7, so we get 11 as our remainder. So we have our dividend, x cubed plus 5x squared plus 7 divided by x plus 1, which is equal to our quotient, which is a quadratic, x squared plus 4x minus 4, and then we add that remainder of 11 over x plus 1. And the last thing I want to note is, if you know that this last term is your remainder, and you start as -4 as the constant, then that must tell you that +4 is your linear term, and then 1 is your quadratic. So that's another way to think about it. Your solution, your quotient, is going to be, that last number is always going to be a remainder. So if you have 3 terms, you're going to have a quadratic. And don't forget the part B way to show our solution, or our answer. And our final problem, our first coefficient is 1. We need a placeholder for our quadratic term. Our linear coefficient's -13 and our constant's -12. That last term's a remainder, and we're going to do 4 because that's the solution of the factor that we have. All right, so we bring the 1 down. 4 times 1 is 4. Added to 0, you still have 4. 4 times 4 is 16. Added to 13, and we get 3. Then 4 times 3 is 12, added to -12, and so we don't have a remainder. So we have our dividend divided by our divisor, which is equal to x squared plus 4x plus 3. And then our dividend equals our divisor times our quotient. Okay, so now we're going to go onto the back and review factoring. Okay, so the way we factor number 1 is by pulling out a GCF. Our greatest common factor is 3. So that comes out in front, and we're left with x squared minus 1. But we're not finished because x squared minus 1 is the difference of 2 squares. So we have 3 times x plus 1 and x minus 1. So now this problem is completely factored, and we can solve since it's set equal to 0. So essentially what we're going to do is take the first factor, x plus 1 and set it equal to 0, and then our second one, x minus 1, and set it equal to 0. So for the first one on the left, x plus 1 equals 0, you would subtract 1 from both sides, and we would get x equals negative 1. Over here on the right, we would add 1 to both sides and get x equals 1. Since it's a quadratic, we have two solutions, and those are it. Number 2 is 5x squared minus 20 equal to 0. This is also a GCF. We can pull out a 5 first. And then again, we're left with the difference of two squares because x squared and 4 are perfect squares, and there's clearly a difference there because we have a minus sign. So we have 5 times x plus 2 and x minus 2. So if we have x plus 2 equal to 0 and we solve that, we get x equals negative 2. Over here, if we have x minus 2 equal to 0 and we solve that, we have x equals positive 2. And those are our two solutions. Okay, so number 3, we're going to have to solve using decomposition. So our first step is to multiply that a value times the c value, and we get negative 20. So then we need to figure out the factors of negative 20 that add to get positive 19, because we're going to rewrite plus 19x as two factors instead. So those factors are going to be a positive 20 and a negative 1. So again, I rewrite that middle term 19x as 20x plus negative 1x. So my next step is that I'm going to group them. Now that I have 4 terms, I have even groups. And the key that you need to know is I always need a plus sign in the middle of it. So please don't write minus x and then forget to take the minus sign with you. It's going to throw you off. So anytime you have a number on this right side in that position, just make it plus a negative, and then you won't even have to worry about it. So the next step is to take a GC out of each of those groups. So the GCF in my first one is going to be 5x, and I'm left with x plus 4. And on the second one, it's negative 1, and I'm left with x plus 4. Now, if you notice, the two factors that we have left in the parentheses are equals, which tells us that we did this correctly. So that is one of our factors, and 5x, and then you can write minus 1 here, is our other factor. So then each of these need to be set equal to 0 and solve. So x equals negative 4. And if we did 5x minus 1 equal to 0, we would have to add that 1, divide by 5, so x equals 1/5. So these are our two solutions for number 3. Number 4 follows the same decomposition method. So we have 6 times 6, which is 36. And the two factors that multiply to give us 36 that add to give us 13 are 9 and 4. So again, we're going to rewrite our original quadratic, but instead of one middle term, we're going to separate them into 9x plus 4x. Now, it doesn't change the value of the problem, it just takes it from 3 terms to 4. We do that, so now we can group them into 2 groups of 2. From each of those binomials, we're going to take out the GCF, and in my first one, I have 3x, and I'm left with 2x plus 3. And in my second one, I'm going to take out a 2, and again, I'm left with 2x plus 3, which tells us we did it correctly, and also that it can be factored. 2 terms in the parentheses still are equal, so we have that as one of our factors. Then we take the 2 GCFs put together, and we get 3x plus 2. So now what we're going to do is we're going to set each of these equal to 0 and solve. So x equals negative 3 over 2 for one of our answers. and x equals negative 2 over 3 for our other answer. Number 5 is the difference of two squares. We have a 4 in front of our x squared, but that's okay because that's also a perfect square. So the square root of 4x squared is 2x. Square root of 1 is 1. So we have 2x plus 1, and we have 2x minus 1. And if I set each of those equal to 0 and solve, I would have x is equal to negative 1/2 and positive 1/2. Now, number 6 is another decomposition problem. So 8 times negative 15 is negative 120. The factors of that add to give us negative 14 are going to be negative 20 and positive 6. So we have 8x squared minus 20x plus 6x minus 15 is equal to 0. So I'm going to group the first two terms and the last two terms together and pull out a GCF. I notice that my two factors in the parentheses are the same, so that's one of our solutions or our factors, and then the other comes from the GCFs put together for x plus 3. And again, if I were to set this each of those equal to 0 and solve, I would have x is equal to 5/2 and negative 3 over 4. Okay, so number 7 and 8, we're going to solve using the quadratic formula. So the first thing it starts with is the opposite of b. So the opposite of negative 4 is positive 4, plus or minus the square root of b squared, which is negative 4 squared, and you need to put it in parentheses or else the calculator won't do it correctly, minus 4 times a, which is 7, and c, which is negative 3. And that whole thing is all over 2a, which is 2 times 7. So when I simplify underneath the radical, I get the square root of 100 over 14. So the square root of 100 is 10, so I have 4 plus or minus 10 over 14. So essentially this is two separate problems because we have plus or minus, and you don't need to write this next step for me if you can actually do the numerator first and then the denominator first. So don't try to simplify here. So technically we have like a we could put parentheses up top there and do, we can do 4 plus 10, which is 14 over 14. So we have 14 over 14, which equals 1. And we also have 4 minus 10 over 14, which is negative 6 over 14, which we have to simplify into negative 3 over 7. So these are both of our solutions for that quadratic. All right, number 8, our last problem, again with the quadratic formula. So we have x equals the opposite of b, so it's going to be a positive 8 plus or minus the square root of negative 8 squared minus 4 times 2 times 16. All over 2 times a, which is 2 times 2, so we have 4 on the bottom. Now, underneath the radical, we're going to get a negative 64. But we know that we can take the square root of a negative number. It just is going to mean it's a complex number. So the square root of 64 is 8, and the negative is I. So we have 8 plus or minus 8i. All over 4. So we have to simplify it, and you can either write it a couple different ways. So the way that I think about it is I go 8 divided by 4, which is 2, plus or minus 8i divided by 4, which is 2i. So you can do it that way, or you can break it up and say, okay, well, this equals 8 divided by 4 plus or minus 8i divided by 4, which equals 2 plus or minus 2i. However you would like to do it, it doesn't matter to me, but sometimes when you do it this cross way, you forget to divide them both by 4, so you just have to keep that in mind. So this is our answer, and since we have 2, some people don't see that our first one is going to be 2 plus 2i, and our second one's 2 minus 2i. So either of these boxed answers I would accept.